Hello. I feel like I need an intro, you know, because I'm like a YouTube star now. I have one new follower. It's weird. This is Larry. Larry is the lemon Sour Patch Man. He's the last of my pups for Sour Patch Man. But I shall steal more from my boyfriend, so have no fear. Anyway, today we're talking about negative exponents. So hopefully yesterday, when you were working with division, you ran across negative exponents. If not, we're going to recreate some situations in which you might. Also going to point out a couple things that I hope you got, but since I can't time travel into next week, I don't know. Let's say we have x to the 4th power over x to the 6th power. Grab a ruler. You gotta get to look at the back of my head. It's great. It's a beautiful head, right? Okay. Now we're gonna expand, just like we did yesterday. We're gonna do x times x times x times x, x times x times x, x times x times x. That's annoying. You probably figured that one out when you were expanding things on the worksheet. So let's figure out an easier way to do it. First we cancel everything, and we're left with just a 2, which leaves me with a whopping 1 over x to the squared. X to the 2nd power, sorry. X squared or x to the 2nd power. Now, yesterday I asked you to look at the exponent, and then look at these two exponents. What could I do to 6 and 4 to get 2? What I was hoping you would come up with was subtraction. Because division, just like multiplication, is repeated subtraction. Multiplication is repeated addition, division is repeated subtraction, which is fun. X to the 4th power divided by x to the 6th power is really just this fun thing. X 4 minus 6, which is x minus 2. And this is where I come in my negative. We'll keep practicing this idea here. I have a negative 2, right? But before, I had a 1 over x squared. Right now I have an x negative squared. These two are the exact same thing, which is the really hard part to learn about negative exponents, is that, we're going to erase everything, so you might want to pause or go back a little bit if you want to take notes on that. 1 over x squared is the exact same thing as x to the negative 2nd power. They're the same thing. If you want it positive, it's going to be on the bottom. So it works. Now, generally when we're working with exponents, we like to have positive exponents. When you do prodigy for the rest of next week, it's going to be positive exponents. So, when you see a negative exponent, all you do is you flip top to bottom. That's it. So I have a negative x over 1, negative exponent over 1. And I flip it, so now it's on the bottom, and it's positive, and everybody's happy because I have no negatives. The negatives only occur because of the shortcut we just discussed, right? If you were to expand everything, you'd naturally end up with x's on the bottom. But because of the shortcut of subtraction, we end up with a negative exponent. That has to be a word called rectified. Rectified basically means it needs to be corrected, okay? So sometimes shortcuts make nice, like for instance, you don't have to write out 100 bazillion x's, but then they also come with some consequences, so you have to correct those consequences. So we're going to do a couple more. I'll expand it like we were doing, I'll do the shortcut, and then I'll show you the negative exponent we end up with. So I'm going to write a little smaller. I apologize if this gets a little hard to read. Let's say x to the 3rd power over x to the 9th power and demonstrate how annoying writing out all of these x's is. Hopefully you think it's annoying. If not, well, good luck. Okay, x times x times x, and then we do all of the x's. This is very hard to do after a shoulder workout. Please appreciate my efforts. Okay, we've expanded. Now we collapse and kill them all. We're left with 1 over x to the 6th power. Okay, So when it's expanded, which really is technically the original and correct way to do it, we get x to the 6th power on the bottom. When we do it the shortcut way, we have x to the 3rd divided by x to the 9th, which is really just saying x 3 minus 9, which gets us x negative 6. Okay, we've done a shortcut way. We need to correct what's just happened, though. This is much quicker than this. To correct it, all we're going to do is we're just going to shift this to the bottom, and that's it. So, shortcut way causes minor error, correct answer. We're going to show you a case in which you're not going to want to expand. I'm going to regret doing this. But here we go. I would normally do this on a gigantic whiteboard to show you why we don't always want to use the expansion option. Although it's more accurate the first time around. No errors have to be corrected. Sometimes you're going to end up with, let's say x to the 15th over x to the 25th. Oh God, what am I doing? Okay. I hope you enjoy this because this is going to be horrible. Maybe I will find an editing software just for this video. Oh, ignore the screaming baby. My neighbors are loud. Okay, 15x's, here we go. You can write this with me so you can share my pain. Okay, 5 more to go. Whew, that's 15x's. Now, 25x's. That's 1 5. It's 2 5s. I'm not sure I can do this, guys. 3 5s. There you go. 25x's. And that is why you don't want to expand all the time. Number one, you start to run out of paper if I give you x to the 100th power. Okay, we'll do that one next. I'm not writing it out. Just not doing it. Now after you've written it out, the real pain comes in. I have to cross every single one out until I run out of x's. Now if you've done this in your head, and you're like, oh, but Miss Knock, I should just be left with 10 x's. You're more correct. But I had to go through all that work just to show you that. So, this is one of those cases where it is not a great idea to write that out loud. Because that whole thing boils down to 1 over x to the 10th. I could have gotten that really easy. I could have just said x to the 15th divided by x to the 25th really just equals x 15 minus 25, which equals x to the 10th negative. And then I flip it. Both equal the exact same thing, but that is a pain to do. Don't do it, please. Okay. I threw my eraser. But where did I throw it to? Eraser. Okay, sleeve it is. Oh, found it. It's camouflaged in the gray blanket. Okay, let's try another one. For some reason, this is a really hard concept for people to get. If you get it, awesome. If you don't get it, please hop into office hours, and I'm sure I can come up with a better way to explain this to you. I'll have a whole week. Okay, let's do a really annoying one. Let's say we have x to the 25th over x to the 100th. No, I'm not gonna write this out. I'm just not. I'm not gonna do it. That right there, you should see is equal to 25 minus 100. Now remember, when you do smaller number minus bigger number, it's always going to turn out negative. Always. So if there's a big, small number on top, big number on bottom, you should have learned this one yesterday, that means you will have things left on the bottom, which results in a negative exponent. So we have x equals 75, because 25 minus 100 is 75. It's negative. And then all we do is I should have 75 x's left on the bottom, because I have 100 x's on the bottom, 25 on top, and I cancel them out. I'm left with 75 on the bottom. Does that make sense? Yes? Maybe? Okay, one more case to show you about negative exponents. This is a little bit different, but the same thing that you guys have been thinking of. Sometimes we like to be tricky and nasty. And we put negative exponents on the bottom. And we do 1 over x to the negative fifth. It's kind of mean to do, but we do it. You're going to see it in Prodigy next week. What this is really telling us, based off the last one, is we have 1 over x to the fifth. Okay? Now all of you are smart cookies out there, and you know that really what I have now is 1 divided by 1 divided by, you have 1 over 1 divided by 1 over x to the fifth. Now what do I divide? I copy, dot, flip. Ha ha ha. And thus I end up with just x to the fifth. Which is a fancy way of telling you that when you have an x negative exponent, just flip the side it's on. Pay no attention to the stomping. Again, nosy neighbors. X to the negative fifth. Flip. That's all you do. So we'll practice it one more time. And I've once again thrown my eraser and I've lost it. Aha. I know. I'm just as forgetful in my own home as I am in the classroom. That's never given a good memory. Okay. We'll do a couple examples really fast for you. X to the negative 10th. Now I could go through that whole thing again, where you divide it and it ends up on top. And that's the logic behind this cheat. If you want to see it again, come to office hours, and I'm happy to show it to you over and over again, but this is not meant to be that long of a lesson. I'm already at 11 minutes. So, you see a negative exponent? Flip it. And make it positive. Boom! Cheat! Enjoy! Okay. You see a negative exponent? Boom! Flip it, make it positive. Let's do it again. But let's be tricky. I have a negative 5 up top, and I have a negative 20 on the bottom. I gotta flip them both. I flip 20 up to the top, so I have x to a positive 20. I flip 5 down to the bottom. Ta-da! And this is the cheat for negatives. Again, if it didn't make sense, please come to office hours and I'd like to explain to you. If you can't make it to office hours, tell me in the poll, and I'll try to explain it next week. Okay, I'm not going to erase this because I'm just going to say bye. Bye! I'll see you for some accessions on exponents.